All right, well, some of you might have some trouble on how to state the quadrants in which angles lie. Um, and it really comes down to really the process of elimination. First off, when you talk about quadrants of trigonometric ratios, you have to know some basic things. The first thing is that all trig ratios are made up of sine and cosine. And I'm going to change this up so you can see it a little bit better. All right, it's made up of sine and cosine. And so what we have here is sine of an angle is really, when you talk about the unit circle, is really associated with the y value, associated with the y value. The cosine of an angle is really associated with the x value when you're talking about a unit circle. All right, when you're talking about a unit circle. Therefore, when we have tangent, tangent of an angle is really equivalent to the sine of an angle over the cosine of an angle, which actually then is associated with y over x. Now, why is that so important? Well, it's so important because that actually helps you remember where sine and all these various trig ratios are positive, negative, and so on and so forth. So, for example, in the first quadrant, when you're thinking about this, since cosine is x and sine is y, what do you notice are the x values in the first quadrant? Well, all the x values are positive. Therefore, cosine is positive. All right, it's going to be greater than 0 in the first quadrant. We also know because cosine is the reciprocal cosine is secant, secant also has to be positive, greater than 0. And we also know that y is positive, so that means sine and cosecant, and essentially all of the trig functions, tangent, all right, of an angle, and cotangent of an angle, all the trig functions are all in the first quadrant going to be positive, all right? All are going to be greater than 0, okay? So all of them are greater than 0 in the first quadrant. Now, when you get over to the second quadrant, though, the second quadrant, something changes because y is positive, however, x is negative. So what are going to be negative here? Well, or what are going to be positive? Well, positive is just going to be all the sine, because sine of an angle is positive. Sine is y, is positive. And therefore, cosecant also has to be positive as well. So sine and cosecant are all positive here. All the other ones are going to be negative because we have cosine is negative, cosecant will have to be negative, and all the other ones would have to be less than that. Okay, so these are positive. In the third quadrant, what's going to be positive? Well, sine, cosine are going to actually be all negative, but tangent, because it's y over x is negative over negative, that makes tangent positive, and cotangent is also going to be positive in the third quadrant. All right, third quadrant. And then finally, when we get to the fourth quadrant right here, what is positive? Well, cosine is positive, all right, because x is positive. We know that secant is positive because x is positive. And we also know that that's about it, all right? And so that's what we know, all right? First quadrant, everything's positive. Second quadrant, y's are positive, sine and cosecant. Third quadrant is tangent and cotangent. And then finally, in the fourth one, cosine and secant, because x is positive there too. Now, why does that help us out? Well, let's say we want to figure out, state the quadrant of the angle, and they give us this criteria. All right, it said that sine of the angle is positive. Well, sine of the angle is positive. That means where is y positive? Where is y positive? Well, that can be in the first and the second quadrant. Okay, now the next question is, it also says that x, all right, cosine of theta is positive, which means that x is positive too. Well, where is x positive? Well, x is negative here, x is positive there, so process of elimination, that has to just be in the, all right, first quadrant, because the other one would be here. Where do they overlap? They both are right there, and so winner, winner, chicken dinner, our angle is going to be in the first quadrant. Does that make sense? I hope that makes sense to you. Okay, we could do this, another example of this. Say we have secant of theta. Well, secant, it says is positive, so that means x is positive. Well, where is x positive? X is positive in the first and the fourth quadrant because that's where x is positive. Cotangent is negative, it's less than 0. And what is cotangent? Well, that's going to be y over x. Well, since x is positive, that means y would have to be negative. Well, y is negative. Well, that's going to be in the, all right, third and the fourth quadrant. Or where do we have overlap again? There is overlap in the fourth quadrant. So this function is actually, all right, going to be, or this angle is going to be in the fourth quadrant. The fourth quadrant. That's where the angle will be. That's where angle theta is. Okay. Now, where can we apply this? Well, let's say we have, we want to evaluate some 6 trigonometric functions. Well, the key thing when we have here is that we have some criteria. We have cosine has a ratio, and then we have tangent, let's say the example, has less than 0. Well, the first thing we got to do is we have to identify what quadrant is this ratio in. Okay. Well, the first thing is this quadrant, cosine of an angle, is positive. Okay, so this is positive. All right, and remember x is positive. So what? It's going to be in the first or fourth quadrant. It also says that tangent, which is y over x, is negative. Well, if x is positive, y is negative, well, that means our angle has to be in the fourth quadrant. So our angle is going all the way around here. When we want to find this out, all right, and solve one of these, the key thing is we find this quadrant because after that, we now want to create our reference angle and use a reference angle. So here's our reference angle we're looking at. We're going to create our triangle here. Cosine has 8. And I'm just going to put that right here. We'll have 8 is our adjacent side. 17 is going to be our hypotenuse. And it's asking us for tangent. Well, to figure this out, we're going to have to find our opposite side because in order to figure out, figure out all of our different ones, all right, our different trigonometric functions, is we have to know what sine of this angle is, what cosine we already have, what tangent of the angle is, what cosecant of the angle is going to be, what secant of the angle is going to be, and what cotangent of this angle is going to be. Once we find this opposite side by using Pythagorean theorem, 17 squared minus 8 squared, and take that square root of that, that'll give us our opposite side. I'll call that O. All right. If you put that in your calculator and you figure that out, we have 17 squared, all right, minus 64, and that's going to give us 225. And if you take that, it's going to give us 15. So we know this is going to equal 15. So we can figure out the sine is going to be 15 over 17. We know tangent is going to be opposite over 8, so it'll be 15 over 8. Cosecant is going to be 17 over 15. This is going to be 17 over 8. And cotangent is going to equal 8 over 15. And we can figure that out. But the key thing that in order to figure this out was we had to know what quadrant it was in. So we could create the correct triangle with reference angle, and we could also place all of our other values. Now, for some of you might be stopping and saying, hey, Mr. Got some chalk. Doesn't it have to be negative? You are correct. And I almost forgot about that. All right, because make sure this is negative, all right, because it is in the fourth quadrant. So all of our y values are going to be negative here. So that should be negative here. This should be negative there. This should be negative there. And this should be negative there. Okay, so be careful. Make sure you find the correct ratios. All right, we're going to go through some more problems like this, but I hope this helps you out. And good luck and God bless in the rest of your problems.